I want to just take a look at one more transformation, and we'll do this one together. But I want to take a look at a transformation where the base is e. So our parent function is going to be f of x equals e to the x. And we're going to remember for graphing purposes that e is about 2.7, but I'm going to label everything exactly. Okay. So if it's 2.7, that's bigger than 1. This is going to be exponential growth. So I've got my point 0, 1 is my y-intercept. I'm going to have a point at 1e. So here's 1, 2, about 2.7 there. I'm going to make sure I label that as 1e. I just used this estimate to get it in about the right place. Okay. And then at -1, my y value will be the reciprocal of e. And since that's between 2 and 3, we're going to be somewhere between a half and a third. Okay. So -1, 1 over e. Okay, now what I'd like to do is sketch g of x, which is going to be -e to the x plus 4. Okay, and I want to just show you how I expect you to label your points. I want them labeled exactly. Okay. So you're not going to be using a calculator to get decimal approximations of things. I want everything labeled exactly, which means there are going to be e's showing up. Okay, so let's create our usual table for what I would do to evaluate things. So here's what I would do to evaluate and the corresponding transformation. So it looks like here the first thing I would do is I would evaluate that power. I would raise e to the power of x. So we're starting off with our parent function. Then I would multiply that by -1. Now remember, if it helps, you can rewrite this as -1 times e to the x plus 4, so that you can see, yes, we do the exponent first, and then we multiply. And after we've multiplied, then we would add the 4. So both of these are happening after the parent function, so they're going to both be vertical transformations. Multiplying by -1 is going to be a vertical flip. Adding 4 is going to be a shift up 4. And remember, we always work away from the parent function. So with vertical transformations, I'm going to be doing this in the same order. Okay. All right. So I'm going to just do them one at a time. So I'm going to do the flip. Okay. So that's exactly what I do to my y values. The x values stay the same. I'm just going to multiply the y values by -1. So now I'll have a point, negative, you know what? I need a little bit more space here. That's okay. I'll just put, since I'm just going to make my x-axis a little bit higher up. Okay, so we'll have -1, -1 over e, and that's exactly how I'll label it. Okay. And if this was between a half and a third, this is just between -1/2 and -1/3. 0, 1 flips down to be 0, -1. 1e is going to flip down to be 1, -e. Now if e was between 2 and 3, -e is going to be between -2 and -3 at about -2.7. So I'm just approximating where that is, but I am making sure that I'm getting it between the right tick marks, which correspond to my integers. Okay. All right, so then I can play connect the dots. That did not change the location of the asymptote because I was just flipping things over this x-axis. The equation of the axis is y equals 0. Multiplying 0 by -1, it's still 0. Okay, so now I want to move things up 4. So that's going to have me keep my x values the same, but I'm going to add 4 to all of my y values. So this point was at an x value of -1. It's going to move up to 4 minus 1 over e. I'm just adding 4 to that. I can either write it as -1 over e plus 4 or 4 minus 1 over e. Now, where is that? Well, right now, this was just a little bit below 0. I'm moving things up 4. It's going to be just a little bit below 4. Okay. So there's my point, -1, 4 minus 1 over e, which is exactly how you should label it, or if you prefer, negative 1 over e plus 4. 0, negative 1, I move that up 4, that's going to be at 0, 3. Negative 1, negative e, I'm going to add 4 to that y value, so that's going to become 4 minus e. Now notice right now, negative e was a little bit below negative 2. So I'm coming up 1, 2, 3, 4. We're going to be a little bit below 2. So we're going to be between 2 and 1. I'm sorry, I have this labeled as negative 1, negative e. It should have been 1, negative e. Okay. And so now it's going to be 1, 4 minus e. Okay. That's exactly how I label it. But to see what's happening, if this was between negative 2 and negative 3, if I move negative 2 up 4, it would be at positive 2. If I move negative 3 up 4, it would be at 1. So I'm now going to be between 1 and 2. Okay, so what happened to my asymptote? Well, the asymptote was here. We're moving everything up 4. So this is going to move up 4. So it's going to be at a height of 4. Like so. And then my graph looks like this. Okay. Now, in the last problem, we were asked to state the domain and range and the asymptote, so let's go ahead and do that. Okay. The domain has not changed. It's still all real numbers. But that vertical shift and that vertical flip absolutely changed the range, because now I'm getting y values that are below 4. So my range would be negative infinity to 4. Notice we're not including that 4 because there's no point on the asymptote. We never actually touch it. We just get arbitrarily close. And then the equation of the asymptote is y equals 4. Okay, excellent. So sometimes it feels a little bit weird to have to label numbers like 4 minus 1 over e and 4 minus e, but you've basically got those points plotted from your parent graph, and you know how much 4 is, and you're moving things up by 4, or you're multiplying by negative 1, so you can figure out where those are, but do make sure that you plot them and label them exactly.